Okay, so we're going to be doing basic optimization problems. Okay, so again, what we're doing is we need to find the primary equation, the secondary equation, then use those to get your primary into one variable, take the derivative, find the zeros. Okay, so we're trying to find two positive numbers that the sum is 110 and whose product is a maximum. Okay, so what are we maximizing? We're maximizing the product, right? So that is our primary equation. The product of two numbers, let's say the numbers are xy. That's what we're trying to optimize. Okay? Now, I can pick any two numbers as long as that when I add them together, I get 110. So this is my secondary equation, or my limiting factor. Okay? So that's going to help me get my product into one variable. So you could solve for x or y. I'm going to solve y, so I get my original one into terms of x. So I come back over here, and so my product now is x times 110 minus x. Okay? Now that it's in terms of one variable, I can do my first derivative test, which means the first thing I do is take the derivative. So the derivative of my product is going to be 10 minus 2x. Okay, because you're going to multiply the x in, and you're going to get x squared. Then we set this equal to 0. So we get 110 equals 2x, which means x equals 55. Okay, that's our one positive number. Then we use that to find my y. So y equals 110 minus 55, which means y equals 55. So these are my two numbers. Okay? And you could have done your line test to make sure that that is indeed a maximum, but it will be. Okay? So really simple. Now, find the length and width of a rectangle that has an area of 32 feet and a minimum perimeter. Okay? So, I always say the best thing to do is if you can draw a picture, draw a picture. Okay? So, what are we trying to maximize or optimize? Well, this time we're trying to find a minimum perimeter. We need a 32 square foot area, but we're minimizing the perimeter. So what is perimeter? Perimeter is the distance around. Well, if it's a rectangle, let's say that side's x and that side's y, opposite sides are congruent, which means my perimeter is 2x's plus 2y's. Okay, so that's what I'm trying to optimize. In this case, I'm trying to minimize it. Now, what is my secondary equation? What is my limiting factor? My area. So area is my limiting factor, which is length times width. That's the area of a rectangle. And in this case, it's x times y. And since my area has to be 32 square feet, that is my equation for my secondary. So again, we're going to use that to replace one of the variables in my primary. So again, I'm going to solve for y. So we get 32 over x. And then this is what we're going to plug in to my primary equation. So perimeter equals 2x plus 2, and this is 32 over x. So my perimeter is 2x plus 64 over x. We take the derivative, so perimeter prime is 2 minus 64 over x squared. That is my derivative. To find my critical points, set it equal to 0. So be smart about it. I'm going to move my negative to the other side. So I get 2 equals 64 over x squared. cross multiply, so I get 2x squared equals 64, which means x squared equals 32, which means x equals the square root of 32. And I don't have to put plus or minus. I mean, technically I could get positive or negative 32, but we know that the side length can't be negative. So again, we take this to find my other dimension. I use that equation. So I come over here and I say, well, then y equals 32 over the square root of 32, which means y also equals the square root of 32. And then, since we're trying to, what does it say? Find the length and the width of the rectangle, we're done. Because we found the length and the width. The length is the square root of 32, and the width is the square root of 32. And again, most of the time when we're dealing with these types of problems with just areas and perimeters, you find that a square tends to maximize or minimize area and perimeter.